All right, so get ready because today we're diving into how Singapore is making physics come alive using open educational resources.
Yeah, using some pretty cool stuff too, not just the typical textbooks and lectures.
Exactly. Think more along the lines of simulations and even hands-on workshops.
Yeah, and it's all part of this program called Open Source Physics at Singapore.
Okay, so kind of giving us a peek into a different way of doing things, right?
I think so. It seems like a pretty forward-thinking approach to education to me,
Definitely. And from what I've seen in the materials, they're laser focused on making physics engaging and accessible,
especially for upper secondary and junior college students.
which is basically high school and early college for the rest of us.
Exactly, and they've put together this entire workshop series just for them called Modeling with Physics Simulations.
That sounds intense. What all do they cover in that?
Well, it seems in a pretty good range of topics, but the real key is that it's super practical.
Practical, how so?
Well, the students aren't just learning about theory, they're actually getting to experiment using simulations.
Oh, that's cool. Using simulations to see how it all works in action?
Exactly. And speaking of simulations, they've got some with pretty interesting titles.
Yeah, some of those really caught my eye too.
Like everything from your classic projectile motion and pendulum models
Right, the basics.
to things like a simulation called rotating rectangular block.
Okay, so they're branching out a little bit there.
For sure. And here's something I thought was pretty interesting. Apparently, all these materials were developed because of a request from someone named Joseph Chua.
So they took a request and built an entire program.
It seems that way. Pretty cool.
Yeah, very responsive. That really speaks to the whole open source philosophy,
Couldn't agree more. A real commitment to responsiveness and collaboration.
which is really what this whole open educational resource movement is all about, right?
Absolutely. At its core.
Okay, let's talk about some of these simulations because some of them sound pretty awesome.
Right. I mean, projectile frog game. Who wouldn't want to play it?
Seriously, that one definitely caught my attention.
I know, it's definitely an attention grabber.
But beyond just being fun, I imagine they offer a really powerful way for students to visualize these concepts.
Oh, for sure. Much more so than just reading about them in a textbook.
Instead of just reading about projectile motion, they can actually see how different variables affect the trajectory.
Exactly. Change something and see the immediate impact. Much more intuitive.
You know, looking at all the different simulations they've developed,
Mm-hmm.
it makes me wonder if this approach has actually changed how students are learning physics in Singapore.
I'm sure it has. I mean, it's definitely designed to tackle some common challenges in physics education.
Like what?
Well, traditional methods are often so heavy on abstract concepts and rote memorization.
Right, which can be a real turnoff for a lot of students.
Exactly. But with these simulations, it becomes about active learning and exploration.
So instead of just memorizing formulas, they're actually getting to experiment, make predictions, and see what happens.
And that's got to lead to a much deeper and more lasting understanding, right?
For sure. So it seems like these simulations are a great tool for making physics more engaging.
Absolutely.
But before we get too carried away, let's take a step back for a second
Okay.
and define exactly what we mean by open educational resources.
Sure. So at its core, it's about making educational materials freely available to everyone.
And we're talking things like textbooks, lesson plans, videos, even software.
Yeah, all of that. Freely available for anyone to use, adapt, and share.
So it's not just about making things free, it's about giving people the freedom to customize them.
You got it. And that's where the real power lies. Allowing educators to build on each other's work.
And constantly improving the pool of resources.
Exactly.
And in Singapore, it seems like they've really embraced this philosophy,
Oh, yeah, they've gone all in and created this whole ecosystem
where the workshops, simulations, and online materials all work together.
to create a really dynamic learning experience.
And it makes me wonder how this approach is changing things in Singapore.
Well, one of the most obvious benefits is that it opens up access to high-quality materials for students who might not normally get those opportunities.
Now, especially with everything being available online, it really expands the reach.
No doubt, but it's not just about the students.
It's about the teachers too, right?
Exactly. They benefit hugely from this model.
Because they can take these materials and adapt them however they need,
Right, to fit their own teaching styles and curriculums.
creating a truly customized learning experience for their students.
And the best part is they can then share their modifications with everyone else.
So it creates this amazing cycle of collaboration.
I couldn't have said it better myself. It's a really powerful example of how open educational resources can completely transform education.
So we've talked about these fantastic workshops and simulations and how
Hmm.
they fit into the larger picture of open educational resources.
And how Singapore is really leading the way in making physics more engaging and accessible.
It's pretty inspiring to see that level of commitment.
This definitely shows what's possible.
But I'm also curious about the challenges.
Right, because I'm sure implementing something like this on a large scale has its hurdles.
So let's shift gears a little and talk about those challenges.
Okay, sounds good.
What are some of the obstacles that might stand in the way of making this kind of open access education more widespread?
Well, for one, you need the infrastructure to support it.
Right. Not every country has the same level of tech development or internet access.
Exactly. So making sure all students have the tools they need is crucial.
That makes sense. And even if the technology is there,
Mm.
I imagine teacher training is another big piece of the puzzle.
Oh, for sure.
Are teachers all over the world really prepared to use these digital resources effectively?
That's a great question, and one we'll explore further in part 2 of this deep dive.
Yeah, that's a really important point, teacher training.
It is. You can have all the best simulations and resources in the world.
But if teachers don't know how to use them,
It's not going to do much good.
exactly. So providing those professional development opportunities for teachers is key.
Absolutely. They need to feel comfortable integrating this technology.
And confident in adapting it to their own teaching styles.
Right, because it's more than just knowing how to use the software.
Oh, for sure.
It's understanding how those simulations can actually enhance the learning experience.
How to design activities around them, how to assess what the students are learning.
Exactly. And that takes a shift in mindset for a lot of teachers.
Moving away from that traditional model where the teacher is the only source of knowledge.
And embracing a more student-centered approach.
Interesting. So in this kind of setup, what's the teacher's role then?
Well, I guess you could say they become more of a facilitator.
A guide on the side.
Yeah, exactly. Less about lecturing and more about creating an environment where students can explore.
And experiment and really figure things out for themselves.
Right. And simulations are a great tool for that kind of active learning.
I can definitely see that.
It lets them really engage with the material in a way that's just not possible with a textbook.
Hands-on and interactive, that's the key.
Absolutely.
We've been talking a lot about how these simulations benefit students, but I'm also curious about the impact on the teachers themselves.
You mean how it changes their approach to teaching?
Yeah? Do you think it does?
I think it can. I mean, when you see your students getting excited about learning, it rekindles your own passion for the subject.
Brings back that spark.
Exactly. And it also pushes you to think outside the box, be more creative in how you present the information.
It's like a ripple effect, not just about students learning physics.
Right. It's about creating a more dynamic and engaging learning environment for everyone involved.
And I think that's what makes this program in Singapore so interesting.
Definitely.
They're not just focused on the technology, they're thinking about the whole system.
The curriculum, the teaching methods, the training, the community.
A truly holistic approach.
Which is probably why it's so successful.
I would agree, and it's definitely something other countries can learn from.
As they explore the potential of open educational resources.
For sure. But, while this all sounds amazing,
Yeah.
I think it's also important to acknowledge that there could be some drawbacks.
Oh, absolutely. Like any new educational model, there are bound to be challenges.
For example, could there be a risk of over-reliance on technology?
That's a good point. We don't want to forget about the importance of real-world experiments and observations.
Hands-on experience is still crucial.
I agree. It's all about finding that balance between virtual and physical.
Simulations are great, but they shouldn't replace everything.
Exactly. And I think no matter how good simulations get,
Mm-hmm.
there will always be a need for good teachers to guide students and make sure they're really understanding the concepts.
Right. Technology can enhance the learning experience, but it can't replace the human element.
You got it. A skilled teacher can provide context, answer questions, and encourage critical thinking.
In a way that a computer program just can't.
Exactly.
So it's not about technology versus teachers. It's about finding the right way to combine them.
Using technology to empower teachers and create a better learning environment for students.
And speaking of students,
Yeah?
I'm curious, how have they responded to this approach?
I mean, are we actually seeing results?
Yeah, is there any evidence that this kind of simulation-based learning actually helps them understand physics better?
That's a great question, and one that a lot of researchers are trying to answer.
So there's not a definitive answer yet.
Not yet, but the research so far is encouraging.
So it's not a magic solution.
No.
But it seems like a valuable tool.
In the right hands, definitely.
It's really exciting to see a country like Singapore taking the lead on this.
It is. It gives you hope for the future of education.
I agree, but I'm also wondering about the challenges of scaling this up
Right, because taking something that works in one place
and making it work everywhere
is
else.
a whole other ballgame.
So let's talk about that. What are some of the obstacles that might stand in the way of making this approach more widespread?
Well, one of the biggest challenges is going to be ensuring equity.
Meaning that all students have equal access to these resources,
Exactly, regardless of their background or location.
which is a pretty huge task when you think about it.
It is, and it's something we'll delve into further in part 3 of this deep dive.
Yeah, equity is a huge issue. I mean, how do we ensure everyone benefits from these advancements?
That's the million-dollar question, isn't it? And there's no easy answer.
It's a complex problem with a lot of factors to consider.
But I think the exciting part is we're seeing this shift in how we think about education.
Moving away from that old model of just delivering information.
Right. It's not about memorizing facts anymore.
It's about creating experiences that foster a deeper understanding.
And hopefully, a genuine love of learning.
And that Singapore model gives us a glimpse of what that could look like on a larger scale.
Imagine a world where every student has access to these incredible learning materials.
No matter where they live or what their background is.
It's a powerful vision.
It really is, and I think it's something worth striving for.
Absolutely.
But like we talked about, there are challenges.
Oh, for sure. We've got to address the access issues, make sure teachers are trained.
And be mindful of the potential downsides of technology.
Right. Technology is a tool. It can be used in a lot of different ways.
And it's up to us to make sure it's being used to benefit everyone.
Exactly.
So as we wrap up this deep dive into open educational resources, I think the main takeaway is that we're at a really important point in education.
We are. We had this opportunity to make some real changes.
To create a learning experience that's truly transformative for all students.
And that's not going to happen overnight.
It's going to take a lot of work, a lot of collaboration.
From educators, policymakers, parents, even the students themselves.
Everyone needs to be involved in shaping the future of education.
And that future is full of possibilities.
Virtual reality field trips, personalized learning plans, simulations that bring every subject to life.
It's really mind-blowing to think about what we might be able to achieve.
But it all starts with a commitment to innovation.
And a belief that every student deserves the chance to reach their full potential.
Absolutely, well said.
I think we've given our listener a lot to think about today.
We have. We've explored some really innovative programs.
Talked about the potential of open educational resources.
And the crucial role that teachers play in all of this.
It's been a great conversation.
It really has. And I hope it inspires our listeners to keep learning, keep questioning.
And to keep pushing the boundaries of what's possible in education.
And if you come across any other cool projects or resources like the ones we talked about today,
be sure to share them with us.
We're always looking for new deep dives.
Until next time, keep exploring and keep learning.
And that's a wrap on this episode of The Deep Dive. Thanks for joining us.